This video has half a dozen exercises for revision. You can either try to do them yourself first or just use the method to see how it goes following along with me. So this is what I'm going to do. I'm going to label my right angle triangles each time. Then if they have two sides and I want a third, I use Pythagoras. If I'm given an angle and want a side, I use trig. And if I'm given two sides and want an angle, I use inverse trig. Then I make sure that the answer makes sense. I haven't forgotten to square root or done something equally silly. So first up, question 1. We label, and we see that relative to the angle 51 we have the hypotenuse and the adjacent. Angles involved, it's a trig question. Sakata, and A and H are related by cos. Now you notice, although this side is labelled A as our unknown, it's actually the hypotenuse. The adjacent side is the one adjacent to the angle. You have to ignore letters given and use the A and H based on the sides, not how they happen to be labelled. So we're going to use cos, and we're trying to find the hypotenuse. Well, the hypotenuse is A over C. Our A is 84. C stands for cos of the angle, cos of 51. We stick it in our calculator and we get our answer. Question 2. Relabel. This time, relative to the angle we want, x, we have the adjacent and opposite sides. It's trig, and we see the adjacent and opposites are related by tan, toa. So we're trying to find the angle, trying to use inverse trig, where tan is opposite over adjacent. So we go shift tan, 45 over 22, which our calculator tells us is 63.95. We have a quick look. This side's longer than this side, so that's about the right size for that angle. Pretty comfortable, that's right. Question 3. Label, but there's no angle involved. It's not trig, it's Pythagoras. So h squared equals a squared plus b squared, but our 14 is our hypotenuse. We're not trying to find a long side, we're trying to find a short side, so we have to rewrite it in the form to find a short side. A squared equals h squared minus b squared. Then it's just a simple matter of substituting in our numbers. Square root of 75 is 8.66. That's what we want. We need a shorter side than 14, so we need to use subtraction. Question 4. Label it, the hypotenuse and opposite the angle. It's a trig question, and O and H are the sin relationship. We're trying to find the opposite. So when I take O out of that triad, I get S times H. Sin of the angle, sin of 38, times 4.3, gives my answer of 2.65. Question 5. Label it. Our A is H. No angle involved. It's Pythagoras. This time we actually want the long side, so we have to add the squares of the other two sides. 16.1 squared, 7.8 squared. That number, which we square root, because obviously the answer is not 320, and 17.89, that looks about right. Last question, question 6. We label, have hypotenuse and the adjacent, so trig, and A and H are related by cosine. We want to find the angle, so this is inverse trig, and we know that cosine of the angle is A divided by H. So our angle is shift cos A, 12 divided by 21, our H, and the calculator tells us that's 55.15 degrees. That's the process. Label. If you have an angle, then you use trig. If you want an angle, you use inverse trig. Otherwise, you use Pythagoras. And at the end, you just have a quick check to make sure that you haven't stuffed up and forgotten to square root or done a division when you should have done a multiplication.